Hello, let's continue our Sudoku adventure with On All Fours by James Kopp. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these digits outside the grid. They're all fours. That's hence the title. They are both sandwich sums and skyscrapers. Those are both standard constraints, so I'm going to go over them separately. So the way sandwich sums work is you look at the row, or the in this case, this row, or this column, and you look to see where the 1 and 6 are. So maybe the 1 would be here, and the 6 would be, I guess, 1 would be here, 6 would be here, maybe. And in between that, the digits have to sum to 4. In this case, they have to sum to the clue. So that would be a 4 there. If this is where the 1 and 6 are, we put just a 4 between them because they'd have to add to 4. So that's one example. And that's how the sandwich sums work. We also have skyscrapers in the grid. Sorry, these are also skyscrapers. So the way I describe this is imagine you're standing on top of the clue, looking down the row, looking at the row from standing on the 4, right? Or here looking at the column from the 4. And we're going to count how many skyscrapers we see, where the digit in the cell is the height of the skyscraper. So if I did, say, 1, 3, 2, 4, 6, 5. I'm going to mark in green any cell that's seen. So you always see the one that's right in front of your face. And then you also see ones that are bigger than all of the previous ones. So we see the 3. 2 is not bigger than all the previous ones, so we don't see it. The 4 is bigger. The 6 is bigger. The 5 is not bigger than all the previous ones. It's smaller than the 6. And now we count how many green cells we got, and that's 4, and that matches the 4. So this is the count of how many skyscrapers you see. Remember, they are both sandwich sums and skyscraper glues. So there's kind of a duality there. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so I tried very hard in my example not to give away, although it's kind of the first thing to think about, but that a 4 sandwich sum must be just a 1 and a 6 surrounding a 4 somewhere, like here. You can't do a 1-3 pair inside of the 1 and 6. You'd repeat the 1. So you're not allowed to use the 1 in the sum. And we can't do 2 and 2. That would repeat the 2. You can't repeat digits in rows or columns. And so the result is that it's always a 4 surrounded by a 1-6 pair, wherever the sandwich is. So it could be here. It could be, let's see, where else could it be? These 4s are very well placed. It could be something like here. All right. So there's a few options. I suppose I could note that 4 is in one of these two. And so this clue is kind of our starting point. You can't put a 4 here because we can't surround it with the 1 and 6. So this is a 1-6 pair. And that makes this a triple, the rest of them, 2, 3, 5. That makes this 2, 3, 5, and then this is also a 1-6 pair. All right. Now, from here we need to see 4 skyscrapers. We're going to have the 5 over here, which means that the 1 and the 6 get hidden. Sorry, the 6 is never hidden. That means the 1 and the 4 get hidden. Sorry, I said the wrong digits. I got ahead of myself. So we always see the 6, and the 5 over here is going to hide the 1 and the 4. Now, one easy way to kind of think about the counts is the opposite, which is how many skyscrapers are hidden. And we know that there's a maximum of 6 seen. So in order to get down to 4, we need to hide 2. Well, the 5 here has already hidden the 1 and the 4. That's the max that can be hidden. So this 2, 3, 5 has to go in order so that none of those get hidden. And now it doesn't matter where the 6 ends up. It will fulfill our skyscraper. Okay. All that to explain that, but hopefully that made sense. These 4s look in here. This can't be a 4, again, because we can't surround it with 1-6. So this is our 4. And that does mean there's a 4 in one of these two. And again, it can't be here. So it actually is where my example was. This is a 1-6 pair now. So these are from 2, 3, 5. It's going to resolve our 1-6. It's probably a skyscraper. All right. Now, wherever the 1 ends up here, it is hidden. There's no way we're not hiding that 1 because, well, this is 2, 3, 5, I should say. It's not 2. The only way to not hide the 1 is to put it right next to the clue. Let's see. So we're always going to see this one. We're always going to see the 6 wherever it goes. this can't be a 5, right? If you put a 5 here, then you're only ever going to see the 6 along with it. That's kind of 2. The 5 here is also problematic. We'd see this guy, we'd see the 5, and we'd see the 6, and that's it. That's a count of 3. So the 5 ends up over here. 2, 3 pair puts the 5 here. These are not 5s, and this is the other one 6. Okay. So what about this? This 5 is definitely hidden. Oh, the 1 6 surrounds the 4. I didn't notice that. So we have the 1 and the 5 hidden. So whatever these two are have to go in order. It's the 2 and the 3. That gives us 3 here and 2 here. These are not 2s. I still don't know what's resolving our 1. It's got to be that one of these 4s would have a 1 next to it, but that's just not true. All right, I'll have to think about this. So Sudoku, I suppose. This is a pair, 2, 3. So this is the 2, this is the 3. Am I missing a clue? Did I fulfill all of these? Yeah, this doesn't care. What about here? Okay. So the 5 gets hidden and the 1 gets hidden. So these need to be in order, 2 and 3. That gives us 5 and 3. 2, 3 is seen. We can't put the 6 here. That's what's happening. It resolves the 6. The 6 here we'd only see 3, not 4. So this is 1, this is 6, this is 1, 6, 6, 1, 6, 1. Perfect. Now we just finish. 4, last 4 is here. 2 goes here. The 1 goes here. We need a 5 and a 6. This is 6, so that's 5 and 6. And then we need the 1 and the 5. All right, that was correct solution. Nice. Cool puzzle, James. Yeah, nice way of the sandwich combined with the skyscraper. It was a neat idea to use 4 there because it had some interesting interactions. All right, well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.